Good morning, students. I am Dr. R.Prem Sudha, Associate Professor, HoD Civil. Today I am going to start your class. Our subject is Design of Reinforced Concrete Structural Elements. Here you can see in this screen what is the syllabus. Okay. So first unit it covers with methods of design of concrete structure. What is meant by concrete? I think you are all familiar with the word concrete. What are all the ingredients of concrete? What is meant by concrete? Concrete is a mixture of coarse aggregate, fine aggregate, cement, sand, and water. Okay. So what is the difference here in this subject? Design of reinforced concrete structural elements. What is meant by structure? So what are all the components in the building? First you should know what are all the components in the building. What are the components in the building? If you see the building, what all consist of? You can see the walls, columns, beams, slabs. The slabs may be floor slabs or roof slabs. Okay. So here structural elements, we can say the load which carries the structure carries the load and transfer the load, distribute the load uniformly from the structure. Okay, ba? So structure is nothing but load. Morning, students. I am Dr. R.Prem Sudha, Associate Professor and HoD in Civil Engineering. So I am here to teach a subject, Design of Reinforced Concrete Elements. So here, this page you can see here the syllabus. Okay. So both 5 units. First unit deals with the methods of design of concrete structure, and the second unit limit state method, plant beams, shear and torsion. And the third unit limit state design of slabs and arches. And the fourth unit limit state design of columns, types of columns. The fifth unit is limit state design of buildings. So here in this method, we are going to see about the reinforced concrete structural and how to design. So first, before going into the subject, the basic thing we should know. What is meant by concrete? What are the ingredients of concrete? What is meant by structure? What are the structural components in the building? Okay. So here you can see concrete. What is meant by concrete? Concrete is a mixture of coarse aggregate, fine aggregate, cement, sand, and okay. Then what is meant by PCC? What is meant by RCC? So here we are saying reinforced concrete structural element. What is meant by reinforced? Reinforced concrete. That means that we call it RCC. The reinforced concrete means we are introducing steel into the concrete. What is the difference between PCC and RCC? See, concrete is basically strong in compression and weak in tension. So withstand the tensile force, we are introducing the steel concrete. That's why that is called reinforced concrete. In PCC, that is plain cement concrete without rod. Here we will introduce the rod to withstand the tensile stress. So here RCC is strong in tensile load, weak in compression. Okay. Now here concrete, what is it? So concrete is mixture of coarse aggregate, fine aggregate, cement, and water. Okay. There are different types of concrete. Different types of concrete based on the material we are using. Concrete, we can say grades of grade. Okay. So first, before entering into this subject unit, you should know this the common thing. What is this structure? When we call the building component as structure. So in building, what are the building components? Starting from foundation, wall, column, beam, slab, then roof slab, floor slab. Okay. So why this? These are all the components. in this component, which component we call the structural structures? All these are the structures, but the load carrying member, that is we call as element. That element. So, if we take where the load comes on from the building is from the top, we take roof slab. From the roof, the load is distributed to, load is transferred to beam, and the beam to column, the column to wall, wall to the foundation, foundation to, it is uniformly distributed. Okay. So here, the load carrying member we call the structure. That structure we need to design because it should withstand the load coming from the top and uniform transfer and uniformly distributed soil. Or else what will happen? So that design concept and method of design see in this subject. Okay. So this first unit consists of concept of elastic method. Here you can see concept of elastic method. So design commonly there are three methods. What are all the method names? In the second slide. Okay, that you can see. Here you can see design of different type of structural element. So this is a beam, this picture shows the beam. It is a horizontal member and the column, vertical member. Then it is a slab. Yes. Here you can see introduction, then analysis of design of beam. The analysis can be done by three methods. Okay. What are they? In this you can see what is reinforced concrete. So reinforced cement concrete is a composite material made of steel reinforcement fabric. Then concrete may be assumed to work purely in compression, whereas the reinforcement is because tension. Okay. Then what is the purpose of using reinforcement? Here you can see this all use the details of RCC. Then what are all the elements of I told. What are all the elements? Beam, column, floor slab, foundation, slab, staircase. Okay. Then what are the methods available? Here you can see the elastic method of design of reinforced concrete or modernization. The elastic behaviors of material are design. So the method of elastic design of structure is defined as method which is the structural usefulness of the structure. So here this working stress method is like here we consider the concrete aspect, but it is not practically applicable. But assumption we are assuming that concrete is a elastic material. This method is complicated and it is not economical. Nowadays, we are not using this method. Second method is limit state method. So here you can see limit state method is defined as method which limits the structural usefulness of the material of the structure up to certain load and with acceptable limit of safety and serviceability are applied so that failure of structure does not occur. So, till the structure lies in this, we'll consider the strength and safety and serviceability that deals the limit state method. This method is advanced method over the other two methods. So, first method is working stress method. Second one is ultimate load design method. The third one is limit state method. So what is the disadvantage in the both methods is these methods are not economical. Then it is tedious to design, but it's considered only the stress at the load point, But here, if you take limit state method, it takes the load considered at the both the poles. Okay. For this subject, we will use the code book. Okay. IS 456-2000. Indian Bureau Standard 2000. Here you can see some technical terms. Define characteristic load. The characteristic load is defined as the value of load which has 95% probability of not being exceeded during the life of the structure. Okay. So all these theory parts and the problem formula is given in your code book. Once if you use the code book, you can able to answer. Okay, all this is then define permissible stress. It is very, very important. In the problem, we will use this permissible stress for concrete and permissible stress for steel. So here you can see it is defined as a ratio. What is it? It is defined as a ratio of yield stress to the factor of safety. Defined as ratio of yield stress to the factor of estimate or right? So this factor of permissible stress is very based on the different grades of concrete. It is given in book. Then coming to concrete, as I said, PCC, RCC. Then here, what is the grades of concrete? Grades of concrete already studied in concrete technology. M20, M50, M35, M25, M40. Like that, we designed some concrete. We designed and we studied about that concrete. So what is meant by M and what is meant by 20? So M stands for mix and 20 stands for characteristic